the influence of climate change on the exposure to vectors that transmit infectious diseases at workplaces. I'll be starting by clarifying a few key concepts that will guide our discussion. Then I'll be moving on to global change, to the role of global change and climate change in the transmission of vector-borne diseases. Then we'll be looking at their impact on occupational health, and finally at preventive measures. Okay, so to begin with the definitions, emerging infectious diseases are the diseases that have recently appeared in a population or that are rapidly increasing in incidence or geographic distribution. Emerging infectious diseases are the ones that have previously declined and are now returning in significant numbers. Zoonoses are diseases or infections that can be naturally transmitted between animals and humans, either directly or indirectly. The zoonotic agent causing them can be a virus, bacterium, fungus, parasite, or another biological pathogen. A vector is a living organism, usually a blood-feeding arthropod like a mosquito, tick, or sandfly, that transmits a pathogen between humans or from animals to humans. Transmission occurs when the vector ingests the pathogen from an infected host. Then the vector transmits the pathogen to another host during feeding, after the pathogen has already replicated inside the vector. About 60% of, the World Health Organization says that about 60% of emerging infectious diseases spread globally are zoonotic in a region. In fact, more than 30 new human pathogens have been detected in the last 3 decades, and 75% of them originated in animals. Vector-borne diseases particularly account for 17% of all these diseases and cause 700,000 deaths each year. These diseases disproportionately affect subtropical and tropical regions and tend to impact the poorest populations. Today, 80% of the global population is at risk of contracting at least one of these diseases. In this chart, there are 10 major vector-borne diseases, the pathogenic agent causing them, and the main vector that transmits them to humans. There are several factors that contribute to the emergence and spread of these diseases, but all of them are linked to what we now define as global change. Let's explore the relationship between global change, climate change, and the dynamics of vector-borne disease transmission. Global change refers to the set of environmental transformations driven by human activity, particularly those altering natural systems. 4 of the most major factors related to global change include human mobility and transboundary movements, urbanization, tourism, and migration, increased waste production, especially in areas where infrastructure is unable to manage it. Accumulated waste provide new breeding grounds for disease vectors, such as mosquitoes like Aedes. This species has spread globally, helped by human movement and accidental transport, for example, eggs being laid in water collected in vehicle tires. Animal movement, whether it's natural movements like bird migration or not, like international trade, all of these contribute to the spread of zoonotic agents. When infected animals come into contact with healthy ones, this facilitates the infection and increases the risk of new regions becoming endemic zones. Deforestation and land use changes. Deforestation, whether for agriculture, human settlement, or livestock, is linked to pollution, rising temperatures, and extreme weather events. It also forces non-immune human populations into closer contact with infected vectors. Changes in land use can also impact vector population dynamics. For instance, mosquito populations may lose habitats, hosts, and predators, prompting behavioral shifts and increasing contact with humans. This elevates the risk of outbreaks and introduces the infection into otherwise non-affected areas. Lastly, we've got climate change. It is one of the most impactful aspects of global change. It affects the distribution, seasonality, and reproduction of both the pathogen and their vectors. Let's break this down further. So, as we all know, climate change is related to increased temperatures. Vectors like mosquitoes and ticks are cold-blooded, which means that their body temperature and their metabolism depends on the environment. This way, increased temperatures allows them to spread into northern regions that otherwise would have been too cold for them to live in. Higher temperatures also shorten the extrinsic incubation period, which is the period between a vector acquiring the pathogen and the vector becoming infectious. This extends the transmission window, and it can even extend it into traditionally cooler months. Moreover, pathogens themselves replicate faster at higher temperatures, making outbreaks more likely and more persistent. Climate models suggest that rising temperatures will accelerate the Earth's water cycle. This will produce more evaporation, leading to more flooding in storm-prone areas and more droughts elsewhere. The consequence of this is the disruption of mosquito breeding, because flooding will create new temporary breeding habitats for these vectors, while droughts can concentrate vector populations in small water sources near humans. It is also to be expected more intense and frequent weather events, such as fewer frosts, more storms, flooding, heat waves. It all affects ecosystems, shifting disease vector habitats and amplifying their capacity to spread diseases. Let's now see how all this affects workplaces. Workers in outdoor environments, such as agriculture, forestry, and construction, are particularly at risk. But this issue also affects other workers, such as humanitarian workers, park rangers, and any other worker that is at risk of coming into contact with vectors during the course of their duties. According to a 2024 report from the International Labour Organization, vector-borne diseases such as malaria, dengue, and Lyme disease account for over 15,000 work-related deaths each year. These diseases have become more relevant due to shifting in land use, water storage methods, and the extension of the transmission season caused by climate change. So the question here would be, how do we avoid this? Well, prevention is the key. And fortunately, many effective strategies exist. From the Spanish National Institute for Occupational Safety and Health, we've prepared leaflets and posters providing key information for two of the most common vectors in the transmission of these infectious diseases, which are mosquitoes and ticks. We've also prepared a database called PaseBio, which includes information on various biological disease-causing agents and the specific preventive measures to be implemented against them. Let's now see a summary on these preventive measures against mosquitoes and ticks collected in these posters. Starting with mosquitoes, the first measure is avoid infested areas. Mosquitoes tend to breed in stagnant or semi-permanent bodies of water. The next preventive measure is to eliminate potential exposure sites. Mosquitoes breed regularly in empty or covered containers that collect water, such as buckets, drainage systems, and ground depressions. Eliminating these areas will reduce mosquito proliferation and spread. Workers should always wear appropriate clothing, limiting skin exposure. Clothes should be loose-fitted and light-colored, consisting of long-sleeve shirts, long pants tucked into long socks, and closed-toe boots or shoes. Another measure is to avoid strong-scented perfumes or fragrances, as these can attract insects. And lastly, workers should use approved repellents following the manufacturer's instructions. The products used should only be the ones authorized by significant health authorities or agencies. Now for ticks, the preventive measures, again, avoid infested areas. In this case, ticks are usually found in wooded areas with tall grass and fallen leaves. So it is recommended for workers to stick to clear trails and avoid sitting on the ground. Another preventive measure is to minimize contact with wild or domestic animals as much as possible to reduce the risk of coming into contact with ticks or other vectors. Again, workers should wear appropriate clothing that limits skin exposure. Clothes should be loose-fitted and light-colored, again with shirts that are long-sleeved, long pants tucked into long socks, and closed-toe boots or shoes. Another measure is to apply tick repellents that must be authorized by regulatory agencies, and workers should always follow the instructions on application and the duration of effectiveness. And lastly, workers should carry basic first aid kit that must contain at least tweezers, disinfectants, and gloves in case tick removal or bite treatment is needed in the field. Here are two pictures that are from our ticks poster, showing first one, the body parts that must be carefully checked after working in areas that are at risk of tick exposure. And secondly, this picture shows the correct way of removing a tick in case of bite. Well, to summarize, we've seen how climate change and other global aspects tend to influence the spread of vector-borne diseases, how they impact occupational settings, and the preventive measures to be implemented. I hope this overview has highlighted the importance of introducing climate change considerations into workplace safety strategies. Here are the references, and thank you for your attention.